Now, let's jump to the subject of nanotechnology and nanomedicine. Nanotechnology and nanomedicine refers to the manipulation of matter on a scale of between 1 to 100 nanometers. 1 nanometer is a billionth of a meter, or 80,000 times smaller than a human hair. There are biotech companies right now that are working on medical applications of molecular nanotechnology. Leading-edge biotech companies are now using nanotechnology in order to regenerate human tissue at the molecular level. Such nanomedicine could eventually build or repair every cell, tissue, or organ in your body atom by atom. Nanotechnologists are currently building machines called nanobots. These are blood cell-sized devices that can go inside your bloodstream, into your body and brain, into every cell, and perform therapeutic functions. Scientists have already built nano-engineered blood cell-sized devices that perform medical functions in animals. In fact, type 1 diabetes has already been cured in rats with a nano-engineered device. Researchers are now preparing for human trials. It's predicted that the next decade, the 2020s, will be the golden era of nanotechnology. Nanotechnology and nanomedicine hold the potential to effectively cure age damage, injuries, and diseases. One biotech company has already launched a product to develop nanomedical life extension technology in order to halt aging and reverse its effects. This company predicts it is just a matter of time before we have indefinite life extension and age reversal nanotechnologies. The machines of nanotechnology are really going to be perfected during the next decade, the 2020s. In fact, biotech companies right now are developing treatments via nanotechnology that repair and lengthen chromosome telomeres in animals. As previously mentioned, telomeres are the tips at the ends of your chromosomes, and they shorten each time a cell divides. Basically, the length of your telomeres determines how long you can live. The longer your telomeres, the longer you will live. The shorter your telomeres, the shorter you will live. The problem is your telomeres shorten with age. But using nanotechnology at the molecular level, researchers have been able to keep telomeres not only from shortening, but have been able to lengthen them. Therapies based on this technique may cure age-related diseases and possibly even reverse the aging process itself. In fact, nanotechnologists can now see the day when, via nanotechnology, we will actually create materials and replacement parts starting at the atomic level, atom by atom, that will actually be better than, perform better than our natural biological parts. That is when the incredible potential of nanotech and nanomedicine will really take flight. And this now leads us to the fascinating subject of computer-brain interface. This is another rapidly advancing area. Realize that there are two main problems with the way we humans have evolved. One is our mental limitations. The other is our health lifespan limitations. But biotech scientists are now working to develop technology that interfaces biologically with our human brains. Imagine if our brains could be linked into computers. We would have unlimited memory and greatly enhanced cognition powers. Every human would have the mental capacity way beyond even the smartest Einstein if we could seamlessly interface our brain with the knowledge stored within computers and the internet. Right now, biotech scientists are working on technologies to converge, to morph, if you will, biology with computers. In the future, we may be able to personally interface our thinking and memory capabilities with computers by beginning to make biological links. That is, by making computers out of biological materials and then interfacing these biological computers with our human brains. If we can successfully transfer a person's consciousness, interface an individual's consciousness with a computer, including one's memory and one's thinking awareness, one's sense of I-ness, one's personal identity, if we can transfer that onto a computer through a mixture of biology and machinery, then a person could effectively store himself, his essence, on a computer. At that point, even if one's body is fatally diseased, injured, or simply wears out, he or she could still have their thinking, conscious awareness stored on a computer and then, at a later date, transferred back into another biological body so that one can continue to live and interact with the universe in a three-dimensional, fully self-actualized way. Scientists are actually predicting that such a computer-brain interface may be available by as early as 2025. That computer-brain interface would, in itself, capture a de facto immortality. Considering that both computer technology and biotechnology are expanding geometrically year after year, achieving such a computer-brain interface may not be all that difficult, relatively speaking.